All right, so for this question, we clearly involve unit conversion. We can see that just because they give us a unit conversion chart or ratio in the question itself. We've seen that in the first module for this test, and I used a method called the chart method. Here, again, you can probably get by without it because I think it's very intuitive what we should be doing to these numbers to convert them. But I'm always worried about the harder version of the question where you get distracted or there's some trick and we just kind of mess it up. So I'm going to use this method now when it's easy so that I'm better prepared for when it gets hard. And that's the thing, is sometimes we're bad judges of a hard question versus an easy question. So better to do the hard question version of the solution all the time so you always get it right. So let's take a look at what that would entail for this question. A triathlon is a multi-sport race consisting of 3 different legs. I don't care. A triathlon participant completed the cycling leg with an average speed of 9.7 miles per hour. What was the average speed in yards per hour of the participant during the cycling leg? So we can start just by writing the units, the unit conversion in each column of the chart. So we're given this 1 mile thing, so let's do that. 1 mile is 1,760 yards. So we did that in the first module, and we had a question that was similar. We just kind of wrote the conversions, one on the left side, one on the right side. In order to use this method, what we want to do is eliminate the units. And in order to eliminate a unit, we need to have the same unit on both the left and the right. So basically what I want to do is I want to put miles over here, so that way I can figure out kind of like what the conversion is going to be, but specifically I want to be able to eliminate miles because it's on both sides. So I'm looking at the question, I'm like, okay, where do I see miles? Well, I see miles here. So 19.7 miles. And here's the thing, speeds are actually 2 units. It's a rate, right? It's 19.7 miles per 1 hour. So I'm kind of writing in reverse. I'm doing this on purpose because it doesn't really matter that it's in reverse because the units will take care of themselves. The end result will take care of itself. We don't have to worry about that. As long as I've got miles on the left and miles on the right, I can cross out the units. The numbers stay, but the units go. Now I'm thinking, all right, well, I need to get rid of yards and hours. Well, there's always going to be an X, and that's literally what they want, right? What was the average speed in yards per hour? So there's my last piece here. The yards, we don't know, right? How many yards? So that's X. I'll write yards so it's clear. And that lets us get rid of the yards, but then per hour, right? Well, we did the same thing with the miles per hour that we should now do with the yards per hour, which is that's actually 2 units. So X yards per 1 hour. So in a way, this is a little bit extra than it needed to be because we're including this hours thing when really we don't, it ends up canceling out. Not just because the units cancel, but because 1 hour is not going to affect the math of this at all. The reason I think this is really great though, is that sometimes they might ask for a harder version of this question where they don't want yards per hour, they want yards per minute or yards per second. And in those cases, we can use this method and then be like, okay, well, we got hours here. Let's use, 60 minutes is 1 hour, 60 seconds is 1 minute, and we can do that conversion and include that as well. So this is a really good method for when they get hard because it doesn't really matter whether we have like a more standard ratio conversion, like 1 mile is 1,760 yards, or if our units are a speed or rate where already it's kind of built in that it's 2 units. The system can handle it. But we know we're done now because all the units have canceled out, right? And we've got miles on the left and the right, yards on the left and the right, hours on the left and the right. So now all we do is we multiply down the columns. So we're multiplying, so 1 times 1 times 1 is X, or sorry, 1 times 1 times X is X. And then on the right side, we have 1,760 times 19.7, which is 34,672. Sometimes we're not quite done. Sometimes the X will have a number attached and we will need to divide both sides by that number to kind of get the X alone, the same way we would do it if we were just solving a regular equation. That's kind of what we're creating here. But in this case, X is already alone, so we're just done. That's the answer, 34,672. Don't bother entering the comma. We just enter the numbers. So yeah, many of you probably got this really quickly just by being like, okay, yeah, I'm just going to multiply 19.7 by 1,760. That's not that hard. That feels very intuitive. I totally get it. But like I said, harder versions of this question are going to involve maybe sometimes some dividing. Maybe sometimes you got the time is changing as well, and you've got to deal with 2 different conversions at once. So this system will work even in those cases. So just keep that in mind. Is it's not always going to be this easy, and your intuition might be really, really on point for one version of the question, but The harder versions are going to use your intuition against you. A harder version of this might still really want you to multiply, but that might be the wrong move. So you'll end up down this wrong path because you're just going by your gut and you're not showing your work. This method lets you show your work and verify that you're doing the right thing.